You good?
No, I'm not. I want to say, I can quit. I don't pay, I quit.
Yeah.
I'm cool with that. I'm down. Totally down. All right, Spencer, we're going to put you right here, baby.
All right.
We're going to put you right here. No, you're not 1140. You ain't on that level yet.
Not yet.
Not yet. We're going to put you right here. We're going to go y equals 7x minus 21 over 2x squared minus 3x plus 1. We're going to ask for the horizontal asymptote, the vertical asymptote, the x-intercept, the y-intercept, and the domain. All right? Lainey, we're going to put you right here.
Awesome.
Lainey, we're going to get you to solve 4 to the 3x minus 5 equals 1/8 of 2x minus 7.
Okay.
We're going to get you to find f inverse of x if f of x is equal to 7x over x minus 5. Okay. Sydney, you ready?
Yeah.
All right. So if you're watching at home and you're doing pre-calculus, your problem is 4 to the 3x minus 5 equals 1/8 2x minus 7. And f inverse of x, given that f of x is equal to 7x over x minus 5. College algebra, you're trying to find the horizontal asymptote, vertical asymptote, x-intercept, y-intercept, and domain of y equals 7x minus 21 over 2x squared minus 3x plus 1. Knock out both of them with this one. All right, Greg, you ready?
Yeah.
All right, so here's what we got. Here's what we got. We're going to take out a negative. We're going to get x minus 3. Factor in the bottom, we got x minus 3, and then x squared plus 3x plus 9. That is the difference of two cubes. Again, cubes are done by x, 3, 3, 3. Stealing 1, that's the x minus 3 you see here. That leaves me with x squared, and it leaves me with 9. X squared plus 9. Take out the minus, it's plus, you get 3x. All right. Now we're going to cancel the x minus 3's. We're going to get negative 1 over x squared plus 3x plus 9. Greg, you good?
Yeah.
Sydney, you good? Sydney, did you have it, or are you good now that you see it?
No, I had it. I just didn't
Okay, so you did
do
have
the
it.
negative part. I just didn't pull out the negatives. I had the bottom though.
Okay.
I got the bottom part.
Greg, did you have it all right? All right, good. Now, for this one, Greg, what did you get?
What answer?
Yeah.
X minus 4 over X minus 5.
Okay, what did you get?
This
I got-
one's confused.
Like mine's gonna be wrong.
What did you get?
Well, I had x over x, so I could put equal when you equal 1.
Yes, it is 1.
Oh, really?
Yeah, it's 1. It's x squared plus 5x is x plus 5. This is x plus 5x minus 2. I think you missed the sign there, Greg.
Oh,
Alright,
okay.
x plus 5x minus 2.
Yeah, I don't know why I put, like, for the x squared plus 5x,
Mhm.
I had put in, like, 2 different things.
Yeah, so a lot of people, when they see x squared plus 5x, they're going to want to do this.
Yeah.
Because that's what the x squared means, is you have 2 of these.
Mhm.
But the first rule of all of factoring, is what got you on your test, by the way, is that if there's something common to all of them, you got to take that out.
Okay.
All right, that's the number 1 rule. All right. Now, keep, change, flip. So this piece is going to go on top. That's going to be x minus 4, x minus 2. This piece is going to go on the bottom, is going to be x minus 4. Now we start to cancel. What do we cancel? X plus 5 will cancel.
X minus 2, x minus 2.
X minus 2, x minus 2 will cancel.
X minus 4, x minus 2.
X minus 4 will cancel. X and x will cancel and just become 1. All right. Two x plus 4 plus 3 x plus 3. Up, up, over. Two x plus 8 plus 3x plus 9 over x plus 3, x plus 4. Five x plus 17 over x plus 3, x plus 4.
You don't have to, like, do anything to the bottom, just leave it like that.
Yeah, you just leave it like that. You good? It's just y'all two for right now. Y'all good? All right. Let's try it slightly again. All right. Let's go 3x squared plus 11x plus 6 over x cubed plus, well, we already did that one. X squared plus 30 over x plus 6 squared. go 4 over x minus 7, minus 2 over x plus 5. Let's go 3 over x plus 6, minus 5 over x plus 1, plus 4x over x squared plus 7x plus 6. All right? Give me 1 second. Spencer, what do you got, baby?
Okay, so is there any other way to find the vertical asymptote without factoring? Or is there an easy way to factor it?
Quadratic formula.
Well, I can use quadratic formula?
Yeah, I mean, but that's sending in a nuclear bomb to kill a gnat. Like, I mean, I think it would get the job done, but, so factoring is your best way, but quadratic formula would be your second best
Okay,
way.
and what two numbers am I getting factors of that equal? Is it 3 and 2?
So 2 times 1,
2 times 1?
is 2, and then you're looking for what times what gives you 2, and adds to give you 3.
Okay.
Negative 2 and 1. Now the problem with doing that is when you do negative 2 and 1, you got to divide by the number in front. If it reduces, it's great. If it doesn't reduce, you slide that number in front.
What the? I've never seen it like that. That's great.
Well, that's the way you do it if you want to multiply these two together. If not, you got to do it by factoring by grouping, which is another pain in the ass. So I don't know that any way is greater than the other.
Okay, well, I got a 0 for the horizontal asymptote.
Horizontal asymptote is y equals 0.
Okay.
Vertical asymptote is going to be 2x minus 1, x minus 1, x equals 1, and x equals 1/2. Right?
Yeah, because it's you go with 0 thing.
Yeah. X-intercept.
3.
X-intercept 3, 0. You're setting the top equal to 0. Y-intercept
0, negative 21.
0, negative 21.
That ain't even domain.
Okay, so then the domain, you got to exclude the values here, right?
It's like negative.
Negative infinity to 1/2.
And then union 1 to 1/2.
1/2 to 1.
1/2 to 1 union 1/2 to infinity.
1 to infinity.
I just know which ones like.
Smallest to largest.
Yeah, but like, because the first one you use half. Oh, it is small switch still. Okay.
You good?
Yeah.
All right.
In fact, yeah.
All right, so let's just try it again.
Okay.
All right, I'll leave that up, but I'll just erase this part.
It gets like 2 times harder whenever there's a number in front of the first.
Oh yeah, I agree completely. Cindy does too, by the way. Hey Cindy, number in front of the x squared makes it work, doesn't it? See, if this is x squared plus 7x plus 6, that's not so bad.
Right.
If this is 2x squared plus 7x plus 6,
It changes things.
changes everything. So we'll go x squared minus 5x minus 24 over 2x squared minus 7x. Minus 15. All right, I'll leave the other stuff up. All right, Cody, Jake, Laney, we're on you.
I kind of forgot what the denominator was for like x minus something, 5.
What's that?
For the second problem, I kind of forgot what the denominator was, so I just put the like x negative 5 underneath the 7x.
X minus 5?
Yeah.
Yeah, that's what it was.
Okay.
All right. Two to the 2, 3x minus 5, yeah? 8 is 2 to the negative 3 to the 2x minus 7, yeah? So this becomes 6x minus 10 equals negative 6x plus 21. Right?
Yeah.
Twelve x minus 10 equals 21. Add 10, 12x equals 31. Divide by 12, x equals 31 over 12.
Great.
Yeah? Now, we good, guys? What had happened was what?
We just went to the fourth, so I kept it 4.
Wait, how did you get it to the fourth?
No, I kept the 4 the same, I just went, did the 1/8 was as -2, but that's not how that would work, huh? It'd be -16, or 1/16.
But you totally could have kept the 4 and made 8 4 to the 3 halves.
I could have. But
That's higher level thinking though.
yeah, but I wouldn't.
I mean, you can do it, it's possible, it's just not advisable. All right. So we got, that's why you're here though. You're here to get better. All right, y equals 7x over x minus 5, yeah? So x equals 7y over y minus 5. Seven y xy minus 5x. Yeah? Now, I have a thing with negatives that I kind of like to avoid them, so what I'm going to do is I'm going to move this over and then swing this back. The more direct way would just be to move the xy over here and leave the negative on the 5x, but I think it's prettier if the 5x is positive. And so I'm going to go ahead and move that 5x. xy minus 7y equals 5x. Factor out the y, you get x minus 7. And you get y equals 5x over x minus 7.
Would it be wrong if we just put like the x, 5x over x minus 7 without the y?
Oh, well, you should have put f inverse of x then.
Okay,
Yeah, but I mean, I wouldn't mark it wrong. I mean, plus it's multiple choice. I mean, you just pick the right one.
awesome, good.
All right. We good? Hey, Jake, why do I feel like you just went 0 for 2?
I didn't even get this thing wrong, to be honest.
Okay. Good start, guys. Real good start.
You should have played, but didn't have as much time.
Hey, Cody, what football game was it where y'all fumbled the opening kickoff and they like picked it up and scored a touchdown? Like, I feel like that's what just happened right there. Like, y'all won the coin toss, give us the ball, damn it, and then you fumbled the opening kickoff and they ran it back. Was that Madison? Like, there was one game y'all played where it just like fumbled the opening kickoff, they score, you get it back, fumble the next possession, they score, and I'm like, damn, that's a real quick way to be down 14-0.
No, it wasn't Madison, it was a different team, because we ended up winning that game by like, I think 21.
Oh, did we?
Down, and then, yeah, we came back and beat them by like 21.
Like, I mean, I'm just sitting in the
That was
stands
the only
like,
time they scored, was whenever we fumbled those 6 times, and they didn't score ever again.
like first 2 plays of the game, Spencer. Fumble, touchdown. Like,
It was bad.
You make it work, you make it work.
I'm just sitting there like,
Oh, that was the 3rd game of the season, that was the first home game too. That was
like, I don't know. I just remember sitting there going, are y'all serious?
Yeah.
Like, this is what we're going to do right here, right now.
Oh, it was Nate both times too. It was both times it was Nate. Yeah, he had his ass shredded that one day.
Get that back to the top.
Yes, you got it back at the top. But it's got a 1 in front, so you're good.
Yeah, that's good.
Okay. All right. Do we need to do these again, or what we got?
I'm gonna need to,
Yeah, we're going to just run that back?
run it there.
Okay. Lady, you got it running the back?
Yeah, I gotta leave in like 20, 30 minutes, but yeah.
Well, honey, here's the good news.
Yeah?
There ain't a lot of people here today, so I should be able to get right back to you.
Awesome.
All right. Let's go 27, 4x minus 3 equals 9. Yeah, you know what, 1/9. 2x plus 5. So let's go there. let's go f of x equals 7x over 3x minus 4. We'll find f inverse of x. And then, Laney, for you, a little surprise twist here.
Oh,
A little gift out of the closet. A little gift out of the closet here.
little plot twist.
Let's go separate into multiple logarithms. ln x cubed y plus z to the 5th over 4th root w plus k. Okay? And then let's bring them together. Let's bring together log base 6 at minus 3 log base 6 y plus 2 log base 6 z minus 4.
Okay.
All right. All right. Oh, Greg, what'd you get for the first one?
Okay. Wait. I know it's kind of messed up, messy.
Cindy, what'd you get for the first one?
I got x plus 5 over x plus 6.
Yes, x plus 5 times x plus 6 over x plus 6 times x plus 6. The x plus 6 is canceled. X plus 5 over x plus 6.
Oh, I haven't got that, but like for some reason I wrote a 3 in front of the x squared on the top part.
Oh, you got rid of it. It was there, but you changed it to different people.
Oh, I was looking for, I seen a 3.
You thought the 3 was still at the beginning and you took it out.
Oh, yeah, no, we made it easier.
Oh, okay.
I'm all about you, Greg.
Alright.
All right, what about this one?
I got
2x
2x
plus
plus
6
34.
over. Go ahead.
Oh,
Not 2x plus 6.
2x plus 34.
2x plus 34.
Yeah.
Yeah.
All right. Why is it 2x plus 34? It's 4x plus 5 minus 2x minus 7. Sydney, you got to be careful here. That minus has got to go with the 2, and it's got to distribute to both pieces.
I did.
Oh, you clearly didn't.
No, I didn't. Never mind. Sorry.
It's all right. I ain't mad at you. 4x plus 20 minus 2x plus 14. And here's the deal, Sydney. It's such a small mistake,
Put it wrong.
but it's a small mistake that counts 5 points.
Right.
You know what I'm saying?
Yeah.
We don't want to give away points.
Right.
We give away enough on stuff we don't know. Can't give them away on the things we do know.
Well, I never got right at the bottom.
All right? Well, this is the same thing. Are you sure you got the bottom one right? Oh, no, you mean the bottom piece over there.
Bottom piece over there.
Yeah.
I didn't say the bottom question, I said the bottom of that one. There you go.
All right, so we're going to go up, up, over, right? We're going to get 3x plus 3 minus 5x minus 30.
I didn't get past this. I can do the long one.
Three x minus 5x.
No, they don't.
3x minus 5x is negative 2x. 3 minus 30 is negative 27. Now, here's the thing here.
Still have to add the 4.
Because the bases are the same, you don't have to do up, up, over anymore.
Right, it's just.
Right? Once you get the denominators the same, you're straight across. Negative 2x plus 4x, 2x minus 27, over x plus 6, x plus 1.
I got that one right. I didn't get the other one right.
All right? We good? Y'all straight? certain numbers are not in the domain. Divide x squared minus 49 over x plus 7, no, x plus 6, divided by x squared plus 14x plus 49 x squared plus 14x plus 49 over x plus 6. Divide those. All right, Spencer. Spencer, we on you. Horizontal asymptote, what did you get?
1/2.
Horizontal asymptote is y equals 1/2. When the degree on top, degree on bottom are equal, we go after the coefficients in front. All right, vertical asymptote, what do you get?
-3/2 and 5.
Log based on 6.
2x plus 3, x minus 5. That's -10 plus 3 is -7. Perfect. So your vertical asymptotes are x equals -3/2 and 5. How did you get that? Factoring or quadratic formula?
Factoring.
Okay, good. X-intercept, what do you got?
I factored it, then I know what to do with what I fact. Like I got.
Okay, so once you factor it, it's x minus 8, x plus 3, is that right?
Yeah, I got -3 and -20.
Okay, so then that's what you put.
Oh, okay.
8, 0, -3, 0 if you want to look smart.
Okay.
All right? If not, just put x equals -3 and x equals 8.
Okay.
Y-intercept, what did you get?
I got. I can't read my own handwriting. 8/5.
0 and 8/5. Very good. What's the domain?
-infinity, -3/2, union 3/2, 5, union -3/2, infinity.
You good?
Yeah, the stuff we went over yesterday, I told you in class, I had no idea what was going on.
Doing that next.
Okay.
All right, so we're done with this.
Yeah, yeah.
All right. All right.
I think I can kind of do this.
You can do that. Let's try this. I'm sorry, I'm thinking about the other dude again. Doesn't do math.
Yeah, that's one I'm like.
All right.
Alright.
We'll do that. All right. Jake, you got it? You got the first one.
I'll go 1 for.
All right. What did you get for the first one? How'd you do it?
I set the base at 3, so the first one's.
3 to the third,
And then the other one's negative second.
3 to the -2.
Yeah. Yes.
All right. So then you got 12x minus 9, -4x minus 10. Is that right?
Yep.
So then you got x equals 1/16.
Negative 1/16.
I agree with that. Laney, we good?
Yep.
Cody, did you get the last one? Not over there.
I got those two. No, I'm gonna need you to go slow on that one.
All right, let me go slow. Y equals 7x over 3x minus 4.
Yep, I got there. I didn't pass that.
Now you're swapping the x and the y.
Okay.
Okay. So now you're going to multiply by 3y minus 4 to both sides. Now your whole goal here is to solve for y, yes? So at some point you got to get the y's on the same side. You agree? So we got 3xy minus 4x equals 7y. Do we agree?
Yep.
Now we got to get the y's on the same side. I moved the 4x over just to make it positive. That's what I do. You totally could just take this and move it over there and be done. It doesn't, there's no harm in either one of those. All right, but for me personally, I move the 4x over, turn it positive, and then I bring the 7y back this way. Does that make sense? That's just my own personal choice. Okay, I'm not saying it's the way you have to do it, it's just the way I do it. 3xy minus 7y equals 4x. Now I've got the y's on the same side, so how do I solve? So we're solving for y though, right? So we got to factor the y. 3x minus 7 equals 4x. Divide by 3x minus 7, divide by 3x minus 7. All right, we good?
Yes.
All right, Laney, in light of the fact that you got to get out of here, we're going to go ahead and go through these two. Greg, I'm coming to you in a second. Are you done already, Spencer?
No, I don't even know how to do the 3.
Oh, yeah, so you've done that.
Yeah.
Just different levels of done.
Yeah.
All right. Anything on top gets a plus, anything at the bottom gets a minus. Any exponents come to the front. So 3 ln x, it's on top. This is on top, so 5 ln. Now, if it's in parentheses, Laney, we want to keep it in parentheses.
Okay.
Okay? Jake, in parentheses, let's keep it in parentheses. And the bottom down here would be minus 1/4 ln w plus k.
Great.
We good on that? Now we're going to bring these together. Anything with a plus in front goes on top. Anything with a minus in front will go to the bottom. Log base 6. X got plus, it goes on top. Z minus 4 squared goes on top. Y to the third goes on bottom.
I get that.
Why?
Better than that.
Oh, okay, gotcha.
Minuses go on bottom. Positives go on top.
Okay.
We good? Jake, you good? What's wrong, Jake?
Just, I don't know, it's just hard, I guess.
All of it.
Yeah, so remember, Jake, I mean, essentially we're using these three properties. Log AB goes out as log A plus log B. Okay? And that may not make any sense to you, right? Like, I mean, some level, you probably are stuck between, I want to understand it and maybe I should just memorize it. Let me remind you, Jake, that if we have 8 to the third times 8 to the fifth, what do we do? Let me remind you that logarithms are exponents. So when you're multiplying, you have to add. What do you do when you divide? So if you have A divided by B, you subtract. Yeah?
What's the difference between ln and log that?
Nothing.
One is base E.
One's base E and one's base 10.
How does that apply?
Huh?
How does that apply?
Isn't LN like science, right?
Yeah, LN is more for science. Spencer. Do you have your keys? You have your keys.
Yes.
Is it like multiple keys are we looking for?
Okay, so if you have multiple keys, okay, thank you. Each one of these serves a very specific purpose, yeah?
Yeah.
And you probably, I don't have any idea what the hell they're for. But if somebody asks me, what are these keys for? I go like this. They probably open something. You follow me? This one might be LN. So it's very exclusive to E. If you don't have an E, you probably wouldn't want to use it. Right? This one might be log base 10. If you have a 10, you want to use it. This one is like log base 6. If you have a 6, you want to use it. Now, the benefit is, unlike keys, if you have 5, you look at it and you go, well, none of these work because I don't have a 5. You can use log 10 or ln and adjust it, and then it'll work. All right? So E, ln is E, log is 10. It just tells you what it's going to unlock when it gets done. All right? So they're just different ways. They're just different. They're different keys for different problems. All right? But ln and log are the two that are on the calculator, so they're the two we use. All right? If the calculator uses log base 7, we'd be using it. But the calculator uses 10 and E. Those are the only two that the calculator does.
Yeah.
So hence they're the reason why we use the ones we use.
So what if you own a calculator that doesn't log base 7?
Well, then you could use log base 7, but it doesn't because no calculator does. Now, if it does, all it's doing is converting it using log base 10. It doesn't do log base 7 natively, I promise. All right, it doesn't do it natively. All right, and then if you have 8 to the 5th raised to the 3rd, you multiply. Exponents being raised to exponents, and so log A raised to the B becomes B log A. You'll see this later. Chapter 5. Great. Next test.
Great.
Not test 4, test 5. Okay. So that's the rule there. All right. That's the rule there. All right. Let me give you guys.
Is that calculus?
Pre-calculus.
Okay.
It's on the doorstep.
Fortunately.
All right. Let's go there.
Oh, wait, it's not going to be with this.
Find the domain, ln 3x minus 7, and log base 7, 100 minus x squared.
Finding domain for both?
Yep. All right. What numbers are not in the domain, Sydney? What numbers are not in the domain, Greg?
Oh,
Greg said, good question.
Because I had put x plus 6 over the factor bottom.
So you factored the bottom.
Yeah.
Now what numbers are not in the domain? The numbers that are not in the domain are whatever makes the bottom 0.
Right.
So the numbers in this case that are not in the domain, -3 and -5. -3 and -5. Those numbers are not in the domain.
Oh, I didn't know this domain was.
Yeah, domain is asking you what x value can you not use. You cannot plug in -3 and you cannot plug in -5. They make the bottom 0.
Okay.
Okay? Now, what did you get here?
I got x minus 7 over x plus 7.
Okay, so you did keep change flip, yes? X minus 7, x plus 7 over x plus 6 times x plus 6, x plus 7, x plus 7, x plus 6, x plus 6 cancel, x plus 7, x plus 7 cancel, x minus 7 over x plus 7.
Can you explain why the first one that? Because like, I didn't write it down, so.
Explain what?
Like, I don't understand the first one.
Number 1?
Yeah.
So if I ask you what numbers are not in the domain,
It's the opposite of what's, is it the opposite of what?
it's, you set the bottom equal to 0. And then you're just figuring out what numbers make the bottom 0. For x plus 3, the answer is -3. For x plus 5, the answer is -5.
Okay. Oh, okay, I got it.
All right?
Yeah.
All right. I'm going to give you another one like the first one. I'm going to give you another one like the first one. And I'm going to give you another one like the second one, although I'm going to disguise the second one. Let's take a look. The second problem is being disguised, just so you know.
Okay.
All right? Spencer, we on you, baby. X minus 4, x plus 3. We're multiplying through by x minus 4, x plus 3. X minus 4, x plus 3. X minus 4, x plus 3, yes? X minus 4 is canceled, you get 1x plus 3. X plus 3 cancels, you get 2x minus 4. This is canceling, you get 5x. X plus 3, 2x minus 8 equals 5x, yes? 3x minus 5 equals 5x. I'm just going to get straight to the good part. -5/2. Shit, I won't go straight to the good part. Subtract 3x. -5 equals 2x. Divide by 2, x is -5/2.
Somehow I got it. Somehow I ended up with x minus 3. I don't know how that happens. That's not even what I factored, but I would have probably done there.
You mean up here?
I got positive there, but somehow I turned it into the negative on the way down.
That's a good idea.
Yeah. I'm
It
not
works
sure-
so good.
Not sure how I did that.
I don't know either. All right, but you got the idea.
Yeah.
Did you see that police officer who was on the news this morning that swerved in front of that drunk driver on the bridge a
Lessons are,
couple weeks ago, last weekend, 2 weekends ago?
Police did that?
Yeah. So she was the last line of patrol on this bridge where they were running the 5K.
Right.
And the drunk driver, I guess, had driven through the barricades and was barreling at all these runners on this bridge.
Yikes.
Oh, yeah, I heard
And
about
then
that,
she-
yeah.
You know, like was gonna try to stop. Freaking drove right into her so she could stop her.
Did she like,
Head-on collision.
did she die?
No. It was on the news, and then they got the cameras everywhere, right? And so they show her, like they show the car coming at her and her trying to
That's crazy.
right into her, head-on collision. I was like, damn, boy, you gotta be real committed.
For real.
I ain't ever gonna be a police officer. I ain't that committed.
That's no sir.
And you know that car was getting up on
Yeah, for real.
it. Like, but I mean, I guess what are the options? It's either that or let the car run into a bunch of people running the 5K.
That's why I don't run.
All right, we're gonna multiply by x plus 3. That's gonna get rid of this, yeah? This is x minus 4 equals 0. Add 4, you get x equals 4, yeah? Now, that's the easy one, okay?
That's the answer, it's just 4.
Just 4. So here, for these two, you gotta do a sign graph. Setting each piece equal to 0, you get -3, +4. And what you're gonna do, Spencer, is you're gonna look to the left of -3 for a value, and between -3 and 4 for a value, and then to the right of 4 for a value. And those are gonna be test points. So we're gonna test a point over here, we're gonna have a test point here, we're gonna have a test point here. The question is it positive or negative? Is it positive or negative? Is it positive or negative? And if it's positive for this test point, it's positive for all the points over here.
I mean, that should always be negative on the left though, right?
Well, so, no, it varies. So I don't want you to get into well, it usually is, or it's this or that, because it varies from problem to problem. Usually it alternates. So if the one on the left is plus, it will usually go plus, minus, plus. If the one on the left is minus, it will usually go plus, minus again. So generally it alternates, but even then it's not always. So you have to ask yourself, are you feeling lucky today? All right?
But like, so that's a line graph, that's a line, right? So
Yeah, it's a line graph.
So anything to the left should be negative.
Well, no. Okay, so let's look at it. The number we plug in will be negative.
Yeah, that number will be negative.
Okay, yeah, that part I agree with.
Okay.
But now the question is, when I plug -8 into this expression,
For X.
is that expression going to be positive or negative?
Yeah, well, yeah, that depends, I guess.
That depends.
Yeah.
So -8 minus 4 is -12.
Yeah.
At the end of the day, all I really care about is we have a negative number there.
Okay.
-8 plus 3 is -5. End of the day, all I care about is a negative number. If I have a negative divided by a negative, that result is a,
Positive.
so on this side we'd say we're positive.
You just choose any number after -3.
Any number after -3. If you plugged in -10, -10 minus 4 is negative, -10 plus 3 is negative. So it doesn't matter what number you plug in.
So you can do 0 for the middle usually?
If it's in between the two numbers, 0 is the only one I go with, yeah.
Yeah.
So 0 minus 4 is
-4.
-4, so it's negative.
And then
0 plus 3 is
Positive.
positive.
Negative.
Negative divided by positive is a,
Negative.
okay. Now to the right of 4, you pick a number,
6.
6. 6 minus 4 is
2. Positive.
positive. 6 plus 3 is
9. Positive.
positive. Positive divided by positive is,
Positive. Okay. So you're just looking for the signs, right? Looking for
Mhm.
numbers as the answer.
No, the numbers don't matter. Because at the end of the day, greater than 0 could be 1/2, it could be 40.
Yeah.
It doesn't really matter, it's just positive,
Okay.
okay? So when's it positive? This side, where else?
On the right side.
This side. So how do you write that?
I have no idea.
Negative infinity to -3, union 4 to infinity. Negative infinity to -3, union 4 to infinity.
Oh, in the middle is the union part.
Mhm.
Okay.
Yeah, the middle is negative, so that generates the union.
Okay.
All right?
If the middle is positive, would it still be union?
No, if they were all positive, you say negative infinity to infinity.
Oh, okay.
Well, not if it's greater than 0, because you got to exclude these two values where it's equal, but,
Okay.
all right? When's it less than or equal to 0? -3 to 4, yes. Now, this is where it gets a little bit confusing, more so than it already is, because -3 is going to get a parenthesis, but 4 is going to get a bracket.
I just know
Okay.
which one needs a bracket.
Well, if it's on top, it's going to get a bracket because you can have 0 on top.
Okay.
If it's on bottom, it's going to get a parenthesis because you can't have 0 on bottom.
Is the second answer always going to be a union, or only if there is a negative in the middle?
Say it again.
Like the negative infinity, -3, union 4 to infinity. Is it always going to be a union answer there?
It's not always, most of the time.
Okay.
It just depends on how the problem sets up.
Okay.
All right. Bye, Laney. Love you, baby. It's almost there. It's just right there. Kwame, you're over here, baby. All right. And then you can get the other problems. Greg, can you show Kwame the problems we've done today? Were you here on campus for class already? Or did you just get here? Okay. All right. Jake and Cody, y'all ready?
Yes.
What'd you get for the first one? Oh, hold on. Don't give me the answer yet. You want to try it again, Spencer?
Yeah, sure.
All right. All right. Go ahead and try that. I'll be back to you soon. All right, what'd you get?
7/3 to infinity.
Who?
Positive 7/3 to infinity.
7/3 to infinity. Very good. Setting 3x minus 7 greater than 0. 7/3 to infinity. Very good. What'd you get for the last one?
10 to infinity.
Not quite. Jake, what'd you get?
You got what I got
Did he get what you got before or after you got it?
after I got it.
Yeah, don't trust his ass. You're setting 100 minus x squared greater than 0. Do we agree?
Yes.
This is a parabola concave down, crosses at -10 and 10. You agree?
Yeah, that's it.
What's it bigger than 0?
Between -10 and 10.
If you need to, do a sign graph. Spencer will tell you how.
Barely.
Hey, Spencer, this is just proof that the sign graph don't go anywhere. Like, you do it today and you're like, oh my God, I can't wait till we're done with this. Yeah, dude, you never
It
actually
is
do
a
that.
forever.
It's a forever thing until you graduate from school and then you never use that shit again.
That's so.
Listen to me, I've never been in Publix when I went. Now's a good time for a sign graph, ever.
So why did we learn
Because you can.
it? That's so stupid.
Keeps me employed. It's the economy going, baby. It's keeping the economy going. All right, we good? All right.
Oh, that'd be cool. That'd be good.
What else, Homer? I told Scott I'd be there around 10:30. He said that was perfect. They would do the other one first and then do the other one. They can do the one on the right. Yeah, not where the TV's going though. Yeah, I'll be down there around 10:30. Appreciate you.
You got a TV player? What you doing?
You know I own a technology company.
Yeah, Dave used to talk about it all the time.
I can't wait till his ass gets back. I got 2 wiring jobs.
What's your company called?
Dryers Technology Solutions. And so they're putting in some cabinets where a TV console thing's gonna go. And they can't put it in until I get there and tell them where the wires have to go, and I mean, it's,
You've owned a lot of businesses though, haven't you? Because I know you have like some kind of like accountant advisory thing you do, right? Where you
so I do, yeah, consulting.
Yeah, but then you build houses, you have this one. You still do all 3, or is it just down to
I still consult, yeah. Whenever somebody called, not anybody called last year and a half or so, but.
Don't know houses anymore though, huh?
No, I've never built houses.
No?
We ran an after-school program for a while. We still do that. I mean, I'm just, I'm trying to scrape 2 nickels together and make $1, you know what I'm saying? That's all I'm trying to do, Spencer, I'm just trying to get to the Dairy Queen. I just want a damn blizzard,
You got that $5 gift card.
I'm giving them out to students, I'm not gonna steal your gift card. Although I ain't gonna lie, I thought about it.
Go to Dairy Queen and say, Spencer said you get a free blizzard, and I'll give you one.
That's all I gotta do.
Yeah.
But it's gotta be the one in Lake Wales, right?
Yeah.
I'm gonna go down there today and I'm gonna say, Spencer said give me a free blizzard.
All right.
And then you're telling me they're gonna go like this. Okay, sounds good.
There's a pretty good chance it'll work.
All right. I don't even want the blizzard, but I'm gonna go down and try it just to find out. Because if that shit works, I'm gonna be like, look, Spencer told me to get me 3 hot dogs, a Barley Coke, and a caramel milkshake. All right. What numbers are not in the domain?
So you have to spread out the 2, so you have to do 2, and then x plus 4.
X minus 4.
X minus 4.
Although that doesn't even matter because it's piece we're interested, it's the bottom. But you're correct.
Is it?
And then be positive 6, negative 2.
Positive 6, negative 2. Those are the numbers that are not in the domain. Great job. Great job.
Well, those we don't have like right equation.
Just write negative 62. Or 6 and negative 2. Now this one beats you butt,
Oh yeah, I know.
right? Because when you look at it, you're like, what the hell?
Just put side by side.
Isn't this the same thing you just did?
Yes.
You just did division.
Right.
Keep,
Change.
change,
Flip.
flip the bottom. Like you literally just did this. Except I had them side by side, so that made it easier for you. X squared minus 36 over x plus 5. We keep, we change, we flip. Yeah? Keep, Greg, change the multiplication, flip the bottom. X plus 6, x minus 6. X plus 6, x plus 6. The x plus 6's cancel. The x plus 5's cancel. Leaving with x minus 6 over x plus 6. You got that?
Yeah. All right.
Kwame, you got it?
Yeah.
You good? Greg, you good?
Hold on, I have to try this. Take a picture of it.
All right.
I have answers right there.
I'm gonna erase. All right. You guys get one more. I'll give you a hint.
Oh, boy.
I'll give you a hint. Up, over transforms it into a problem like you just saw. Up, over will transform it into a problem that you just saw. All right, Spencer.
We did do a sign graph for the problem? We might have to do a sign graph, but.
But we can get you some new camera. Tell it at the school, like, you know.
Listen, I told the school, and this is what they brought me.
Wow, that's disrespectful.
And you know what? This one is way better than the little GoPro I was using that they bought me.
I'm all for having a GoPro on your head, though. That would be great. POV.
No. All right, multiply by x plus 6 is going to cancel. That will go to x minus 5 equals 0, which will give you x equals 5. Yep.
Oh, okay, that's how I was trying to remember. So you multiply by the bottom, okay.
Yep. Now, you can't do that here because of the inequality. And the reason is, when you multiply or divide by a negative, you don't know if you're going to have to switch the inequality or not. But
Oh,
since we
yeah.
don't know what x plus 6 is, we're not sure how we got to deal with the inequality.
Yeah, that makes sense.
Okay? And so, for these, you're straight going sine graph. Negative 6, 5. Number to the left, negative 6, what did you use?
I use, oh wait, -6? Oh, I had them switch. I had -5 and 6. That was dumb. Wait, why do you have them switch? That's not-
Because you got a 7 equal to 0.
Oh, you're saying you want 0 first. Okay.
Alright, number to the left of negative 6, call it negative 10. This is negative, this is negative, this is positive, negative, positive. I'll just go ahead and get to the end. Alright, when's it greater than 0? Negative infinity to negative 6, 5 to infinity. When's it less than 0? Negative 6 to 5. Which one do you include?
You include the 5.
Yes. Alright, well that went over like a fart in church. Let's try it again.
Yeah,
This will be your last one.
that was pretty bad.
Let's go 7 minus x over x plus 6
Okay.
equals 0. Greater than 0. Less than or equal to 0. All right, guys, I'll be right back.
Yes, that's what we use. That's 64. It's still real. That's what we use. Where are you?
All right, are y'all ready? Cody, Jake?
Yeah.
So you're setting x squared minus 8x minus 9 greater than 0.
Yes.
That's x minus 9, x plus 1,
Yes.
which is negative 1 and 9. Do you agree?
Yes.
When's it bigger than 0? Bigger than 0 from negative infinity to negative 1. Union 9 to infinity.
Yes.
Stephen? Yeah, hey Jennifer, how you doing? I'm blessed. Can you call me back in about 20 minutes? Thank you. Take care, bye. All right, so we good there?
Yep.
All right, now, this one, probably best to use your sign graph. Negative 7, 4, and you're asking when's it greater than 0? All right. To the left of negative 7, call it negative 10. This is negative, this is negative, this is positive. And between there, call it 0. This is negative, this is positive, this is negative. To the right of 4, call it 12. This is positive, this is positive, this is positive. All right. That's a sign graph. Spencer will give you a new number afterwards. Y'all can meet at Dairy Queen. He'll show you how to do it. Spencer, you got the sign graph figured out yet?
Close.
How do you know it's like positive, negative?
You got to plug in numbers. Like if I plug in negative 10, negative 10 minus 4, is that positive or negative? It's negative, right? Negative 10 plus 7, is that positive or negative? So negative divided by negative is a...
I still yet to like encounter where it goes positive, positive, negative. Like I haven't had that happen yet.
Oh, well, it doesn't ever. It could, but it usually does not. So the only thing that will affect these things, as long as these are all linear, it will always alternate. Either negative, positive, or positive, negative, positive. Where you'll find it screws up is if this has like a square on it. And then all bets are off after that. Once you start dealing with exponents other than 1, then you can start getting some funky things that happen.
What if it's a 3? It would remain the same.
Yeah, 3 would make it the same.
So only even exponents.
Only even exponents will really jack it up pretty good.
All right, so don't do that, please.
Okay, it's duly noted.
Thank you.
You're in pre-calculus though, right?
Yeah.
Okay, I just want to make sure.
I
All right,
don't like that. Hold on.
I mean, we did do those on the last test, actually.
We did.
Yeah.
I don't know.
All right.
I was surprised that I got a 95 and I wasn't going to complain.
Yeah, you probably cheated. All right. Well, you were looking at Jake's paper half the time. I saw you.
Yeah, then we right before turning.
And then right before I turned it in, you changed on the end. All right, I'm gonna leave you guys with that. All right, I've got Florida Power to get to. Evidently, there's a cabinet going in today.
I'm sitting next to Ashley this next test.
Sit next to Ashley.
Yeah.
She's a good one. I tell you, you need to sit next
I
to
sit
her.
next to Mackenzie. I'm sitting right here.
Yeah,
That's when I need to sit.
dude, she crazy smart.
Dude, what's up with that?
Like, I don't know, she crazy smart though, I know that. All right, Kwame, this is it, baby. So you're gonna go up, up, over. Up, over. X plus 4 plus 3x over x plus 4. Yeah? Up, over. 2x plus 5x plus 20. Do you agree? Love you guys. Y'all take care. Yeah?
Yeah.
Do you agree?
Yeah.
Now, from there, simplify. 4x plus 4. 7x plus 20. keep, change, flip. See, with division, it's always going to be keep, change, flip. Now, what cancels? X plus 4, x plus 4. Leaves you a final answer of 4x plus 4 over 7x plus 20. All right. Greg, you good, baby?
Yeah, it's about to try to do
All right. Qual, you good? Sydney, you good?
Yes.
All right. All right. Your values are negative 6 and 7? I'm sorry, this is 7, yes?
Yes.
That's pretty straightforward.
Yes.
All right. From there to the left of negative 6, call it negative 10. Yeah? 7 minus negative 10, minus the negative become
I was
positive,
gonna ask if the sign there does change or not.
so that's positive.
Okay.
Negative 10 plus 6 is negative. Hey, do you mind if Kwame takes whatever's left?
Okay.
You good? You want any more? You want any more? Yo.
Oh, I just thought I'd say, hey, I heard all that yelling in here.
Oh, grab a donut. Kwame, give her. No, seriously.
Dude, I'm like so big.
Well, so am
I
I.
already ate, well, we know that, but we really don't know that. This guy eats all that, I don't want to do it. I'm good, yeah, thank you so much. No, I heard all that yelling in here, I want to make sure you guys are okay. It's Friday, let's have fun, right?
Okay.
Give
All
him some of
right.
those chips, man.
I'm out.
Oh, crap.
I need $25 so I can buy some more.
All right, I'll see you later.
How was Anthony yesterday after he ate one?
That was bad.
Oh,
You had to do it?
I love when he was throwing up. It was so bad.
Anthony, yeah, who else ate one yesterday?
Pops.
Brooklyn was supposed to, but she said that her doctor.
Pops didn't seem
can't.
like that bothered him a bit.
Dude, Pops, his eyes were all of it and he walked out. He was chilling.
Yeah. Pops may not be normal.
No.
Yeah.
Jeez. Yeah, but how-
Anthony,
I was giving yesterday. He looked like he was throwing up when I left.
yeah, he was suffering pretty good.
Yeah, he was just chilling. He was walking out to his car. There was nothing.
Oh. Bye, Mr. Dryer.
All right. Bye, babe. We'll see you later on.
When is gonna be our next test? I have to look it up, don't I?
Thursday, I think.
Oh, shit. Sorry. Okay.
Love you.
See you then.
All right, love you, Greg.
When it's positive, negative, what does that mean?
So positive divided by negative is A.
Oh, negative.
Now it's going to alternate, but we'll show you. Plug in 0, positive. To the left is 7, negative, positive. Negative.
Okay.
Ones are greater than 0.
7.
Negative
Or
6
negative
is 7.
6 to 7, yeah.
Okay. So one thing you got to be careful there with, Spencer, is that you don't include all the numbers you plug into the test points. Because that's the people who do that. Like negative infinity, negative 10.
Yeah.
No. What's less or equal to 0?
Negative 6 to...
Negative infinity, negative
oh,
6.
negative 6. Union.
7 to infinity, right?
That's when it's less than 0?
Yeah, it's when it's negative. This
How
side,
is
this
7
side.
and infinity less than 0?
Because when you plug it in, if you plug in 10, 7 minus 10 is
Oh, okay.
a negative number, yeah.
Yeah.
Negative 3 divided by 16 is a negative number,
Yeah.
okay? So you're looking at like 7 as an actual value
Yeah.
and going, well, 7's positive. Well, yeah, I agree with that, but it doesn't mean the function's positive.
So you're plugging in, whenever you're saying what is greater than 0, you're plugging in what?
I'm plugging in X values and I'm testing the actual Y value,
Okay.
okay? Now, does negative 6 get a bracket or parenthesis?
Parentheses.
Why?
It's not plot.
7?
Bracket.
Because it's equal to. All right?
All right, thank you.
Now let the fun be there.
Gotta go, so you're wired or something.